Back in the late 20th century, supersonic travel was not only possible, it was happening. The Concorde, a sleek, futuristic aircraft, soared across the skies at twice the speed of sound, turning intercontinental travel into something out of a sci-fi novel. But for all its glory, the Concorde had a fatal flaw. One so loud it shook entire cities. The deafening sonic boom that echoed every time it crossed the sound barrier meant it could never fly over land. And just like that, a technological marvel was silenced. For years, supersonic dreams lay dormant. Too loud, too expensive, too impractical. But what if someone could bring it back? What if supersonic flight could be just as fast, but nearly silent? NASA and Lockheed Martin think they've cracked the code. And after years of work, they're finally ready to test their creation, the X-59, a supersonic aircraft designed to rewrite the rules of high-speed travel. The race to break the sound barrier wasn't just about speed. It was about pushing human limits. In October 1947, General Chuck Yeager made history by piloting the Bell X-1 past Mach 1, shattering the invisible wall that had long held back aviation. From that moment, the skies belonged to supersonic flight. Then came the commercial era, a battle between giants. The Soviet Union had the Tu-144, a rushed attempt to outpace its Western rival. And across the ocean, Europe had the Concorde. It was elegant, powerful, and a marvel of engineering. But there was a cost, one that passengers felt in their wallets, and cities felt in their skies. The sonic boom, a thunderous explosion of sound, made flights over land impossible. And when high fuel consumption and skyrocketing ticket prices entered the equation, the Concorde's fate was sealed. By the early 2000s, supersonic travel was dead. The dream of crossing oceans in mere hours faded into history. But not everyone was ready to give up. Scientists had spent decades studying the problem, searching for a way to silence the boom. If they could control the shockwaves, maybe the dream wasn't over. Breaking the sound barrier is more than just going fast. It's a battle against physics itself. When an aircraft accelerates, it pushes air molecules aside, creating ripples just like a rock thrown into a lake. But when that aircraft reaches the speed of sound, those ripples start stacking up, compressing into a powerful shockwave. And then, in a single moment, the pressure bursts, creating what we hear as a sonic boom. Sonic booms aren't just loud, they're powerful. The force can rattle buildings, shake windows, even damage structures on the ground. That's why the FAA banned supersonic flight over cities in 1973, making commercial high-speed travel nearly useless. And yet scientists never stopped asking the question, what if we could change the shape of the aircraft? So instead of one massive shockwave, we get something quieter. That's exactly what NASA and Lockheed Martin set out to do. They weren't just designing a new plane, they were trying to redesign the very way sound moves through the sky. If they got it right, they wouldn't just be bringing back supersonic travel, they'd be revolutionizing it. The key to eliminating the sonic boom lay in reshaping the way air moves around an aircraft. Back in the early 2000s, NASA began experimenting with a concept called the quiet spike, a long telescopic rod mounted on the nose of a jet. It was designed to break up the shock waves before they could merge into a single, ear-shattering boom. It worked, sort of, but they needed something bigger, something better. That's where the X-59 comes in. This isn't just another jet, it's an entirely new breed of aircraft. Built by Lockheed Martin's legendary Skunk Works division, the X-59 isn't designed for speed records or luxury travel. It's built to be quiet. The goal? To prove that supersonic planes can fly over land without anyone on the ground even noticing. At first glance, the X-59 doesn't look like any plane you've ever seen. It's long, narrow, and almost alien in design. That's because every inch of it has been shaped to control sound. The elongated nose, nearly a third of the entire aircraft, is there to spread out the shockwaves, preventing them from combining into a traditional sonic boom. The wings are positioned further back, reducing pressure changes. Even the cockpit is positioned lower, all to ensure that the aircraft slices through the sky in a way that muffles the sound. But that's not all. To save costs, NASA borrowed parts from existing aircraft. The landing gear, taken from an F-16. The cockpit canopy, borrowed from a T-38 Talon. Even the control system has DNA from previous military jets. And yet, despite using old parts, the X-59 itself is something entirely new, so new, in fact, that it doesn't even have a front-facing window. Instead, pilots rely on an external vision system, a high-tech array of cameras feeding a real-time display. giving them a better view than any traditional cockpit ever could. Traditional supersonic jets blast through the sky, leaving behind a trail of sound waves that merge into a single deafening explosion. The X-59, on the other hand, breaks those waves apart. Instead of a boom, it creates a soft, barely noticeable thump so quiet that NASA compares it to the sound of a car door closing. By carefully shaping the fuselage and adjusting how air moves around the plane, NASA has turned the violent shockwaves of supersonic travel into something almost unnoticeable. If successful, the X-59 won't just change the way we think about speed, it will change the way we hear it. Years of wind tunnel testing, computational modeling, and precision engineering have led to this moment. In early 2024, NASA officially unveiled the X-59, marking the beginning of a new era in aviation. By the end of the year, the aircraft's engine underwent its first real test, a high-powered run designed to simulate real flight conditions. Now, the real challenge begins. Over the next few months, NASA and Lockheed Martin will put the X-59 through a series of rigorous tests, pushing it to its limits. And if all goes well, the aircraft will take to the skies for the first time this year. The goal isn't just to prove that it works, it's to gather data, refine the design, and convince regulators that silent supersonic travel is finally possible. The X-59 isn't a commercial aircraft. It won't be carrying passengers anytime soon. But what it represents is far more important. If NASA succeeds in proving that supersonic flight can be quiet, it will send a clear message to the aviation industry. The future of high-speed travel is here, and it's no longer just a fantasy. Already, companies around the world are watching closely, with firms like Boom Supersonic and Ariane Supersonic working on their own next-generation supersonic jets. But the X-59 could be the key that unlocks the door, setting the foundation for a new era of air travel. Of course, challenges remain. Supersonic flight isn't just about sound, it's also about efficiency. Fuel consumption, emissions, and affordability will all play a role in determining whether these aircraft ever become commercially viable. But for the first time in decades, the barriers holding back supersonic travel are beginning to crumble. The question is no longer if high-speed travel will return, but when? If you're as excited about this as we are, don't forget to like, comment, and share your thoughts. Could supersonic flight change the way we travel forever? Is the world ready for this revolution? Be sure to subscribe for more, because the future of aviation is happening now, and you won't want to miss it.